So valence electrons. These are electrons that are in the outermost energy level. Okay, and so I'm going to show you how this looks on electron configuration. Um, Highest principal energy level in the S&P. So that's the large number that is on your electron configuration. The maximum amount of valence electrons that you can have are 8. So you can't have any more valence electrons than 8. If you do, you've done something wrong. Okay, so 8 is the magical number. And the reason why these are important is because they are involved in bonding. Okay, if you take a look at your periodic table, these are in groups A on your periodic table. So what do I mean by group A? Okay, um, Group A are representative elements, which, yes, we haven't used that term before, but they are going to be elements that are only in the S&P. So they are only ones that are in this block and here. Okay. Wow, I kind of went crazy there. So only elements that are going to be in the S&P are what we're going to look for valence electrons. Now, you know the ones in the middle, still the transition metals, still do have bonding. It's just they're different and they're really hard to figure out. So if we were to look at, let's say, sodium. Okay, so sodium has 11 electrons. Its electron configuration, 1s2, 2s2, 2p6, 3s1. So we want to figure out how many valence electrons does it have. So you need to look at what is the highest energy level. Okay, and so if you're looking at this, the highest energy level here is 3. All right, and you figure out, okay, how many electrons are in that energy level? So in this case, there's only 1. So sodium has one valence electron. There's only 1 electron in that highest energy level. Okay, let's say we look at arsenic. Okay, we're going to use the noble gas notation for arsenic. Okay, so AS. So argon is in front of it, and then we have 4s2, 3d10, and then 4p3. Okay, and so again, you want to look at the electrons in the highest energy level. So we have energy levels of 4 and 3. Okay, so energy level 4 is a higher number than 3, so that is why it is the highest energy level. So we actually have 2 spots. So both of these are considered the highest energy level, the S and the P. Okay, in the slide before it, it says anything that the groups that are in S and P. Okay, so for arsenic, it has 2 electrons in the 4s and then 3 in the 4p, so it has a total of 5 valence electrons. Okay, and if you kind of pick up a pattern, in group 1A, oops, I run out of room, 1A has 1 valence electron. So anything that's in this group is going to have 1 valence electron. 2A has 2 valence electrons. We're going to skip the transition area all the way over to 3A has 3 valence electrons. 4A, 4, 5A is 5, 6A, 6, 7A, 7, and 8A, except for helium, has 8. Okay, so it's a really easy way to figure out valence electrons, but you want to, if you look at the electron configuration, it is the highest energy level and how many electrons are in those energy levels. Okay, these are the electrons that are involved in bonding. The other electrons are just inside. They're actually, it's called electron shielding and stuff like that, which we'll get into later on, but they are not involved in bonding, only the ones that are in the outermost energy level. Okay, so this is really tiny, I'm sorry. So what are we going to do with these? So electron dot structures are going to help us figure out where they're just a way to represent this. Okay, so what you do is you put the symbol, okay, on in the middle, okay, and one dot represents each of the valence electrons. So we just did arsenic on the slide before, okay, and we realized that it has 5 valence electrons. Okay, so since it has 5 valence electrons, we put AR in the middle, and we're going to put 1 dot on each side, and that's going to represent each of those orbitals, because in S and P, when we add them together, they have 4 orbitals. So you're going to kind of think like there's a kind of like this box around the edge, and you're going to put 1 electron on each side of that. So we'll put 1 electron on the top, 1 on the side, 1 on the bottom, 1 here, and then with Hund's rule, you just start doubling them up. So then, since we need 5 total, we'll put 1 back on the top. Okay? You don't need to put that box in there, but that is how it would look. Okay? So some examples of this will be on the next slide, I think, or maybe not. All right, so if we looked at lithium, let's just do one from each group. Okay, so if we did lithium, its electron configuration is 1s2, 2s1. Okay, so its highest energy level is 2. So we would just take lithium and we're going to put 1 dot. Okay, so that's its electron dot diagram. Okay, in the second group, if we were to do magnesium, okay, magnesium, if we write out the noble gas notation, it is Ne and then 3s2. So magnesium would look like, put Mg in the middle, and there's only 2 electrons in that highest energy level, so we put 1 on each side. So that's what magnesium would look like. All right, if we did indium, okay, so In, its electron configuration is Kr. All right, and then it is 5s2, 4d10, and 5p1. And so again, you want to look at the highest energy levels. You need to look at both 5s and 5p. So there's a total of 3 electrons in this. So when I write out my dot diagram, I would draw 3. Okay? All right, let's do a couple more. If I were to look at carbon, okay, so carbon, it has helium, and then it is 2s2, 2p2, so there's a total of 4 electrons. So we put carbon in the middle, put a dot on each side. Okay, if we were to skip all the way to group 7, so if we did bromine, okay, so bromine is, its notation would be argon, and then 4s2, 3d10, 4p5. So again, in the highest energy level, it's the 4s, and there are 7 of them. Okay, so 2 and 5. So we would put bromine in the middle, and we would start by putting 1 dot on each side, and then we would pair them up, right? And that's what electron dot diagram would look like. The maximum amount you can have is 8, but it's pretty easy, pretty simple. Okay, just 1 dot on each side, then each pair them up. Okay, so if you have questions, let me know. There will be a worksheet for you to fill out as well.